Let's do example number 2. How can we find the zeros of the function defined? We just saw this function, but how can we actually find the zeros? The first thing is put function is equal to 0. That will give you the equation x cubed plus x squared minus 9x minus 9 is equal to 0. Let's factor this equation. So I see in the first two terms, x square is in both of them. I can factor it out. I would be left with x here plus nothing. So that is 1 here. In these two terms, negative 9 is in both of them. I factor that out. I'm left with x here and nothing. That means plus 1 here is equal to 0. Now x plus 1 is common factor in both of the terms. I can factor out x plus 1. What will be left here? X square minus 9 is equal to 0. Now, zero product property. Product property says if product of two terms is 0, then either x plus 1 is equal to 0 or x square minus 9 is equal to 0. This would give me x is equal to negative 1. This would say x square is equal to 9, which will give x is equal to plus minus square root of 9, which is plus minus 3. So I have three zeros. Negative 1, 3 and negative 3. Next we have touch points and cross points. Let f be a polynomial function, c be a real zero of the function. Then the point c0 is x-intercept. We talked about it earlier, right? So graph of the function, polynomial function, has x-intercept at the points where we have the zeros of the function. If c has odd multiplicity, then the graph crosses through. So let's say how that would look. If we have a function f of x, if it has some number c, real number is 0, then the graph, if c is a odd multiplicity, then graph just passes through it. So this point is called cross point. Okay, the graph just passes through it at that point if when c is a 0 of odd multiplicity. But if c is a 0 of even multiplicity, it is still x-intercept, but the graph touches the x-axis at c. How will that look? It is, say suppose c is there, the graph would somehow come to that point, touches and turns back around. So at c0, we call that point to be a touch point, either a cross point if the multiplicity is odd, touch point if the multiplicity is even. Okay, let's use this in an example. Number 3, determine the zeros and their multiplicities and what kind of points they are. So we have this first function. If I put this function equal to 0, I have the equation equal to 0. So my zeros would be x is equal to 4 from the first one with multiplicity. What will be the multiplicity here? 2. Why? Because this factor is coming 2 times in the polynomial, right? This 2 is an even number. That means 4, 0 is a touch point. Remember, we said if we have even multiplicity, we call it to be a touch point. Means the graph will touch at 4, 0 to the x-axis and then turn back. From the second factor, I get the 0 of negative 5 by 2 with what is the multiplicity of that? is equal to 3, right? Because this factor is repeating 3 times. Now 3 is a odd number, so at negative 5 by 2, 0 will be a cross point, meaning the graph will pass through at that point. Let's look at the second example, part B. This polynomial function n of x is given to be x raised to power 4 minus 2x square. I can write this as x 4 minus 2x square is equal to 0. That becomes my equation. I can factor out x square. That would look like this. So x is equal to 0 or x square is equal to 2. That will give me x is equal to plus minus root 2. So there are 3 zeros, root 2, negative root 2. 0 is with the multiplicity. What is multiplicity of 0? For 0, that is 2. For this, it is 1. For this, it is 1. Because 0 is repeating 2 times. Each of the other ones are repeating 1 time. Okay. So we have at 0, 0 will be touch point. At root 2, 0 and negative root 2, 0 will be cross point. Let's look at the graph of this function. So we have x raised to the power 4 minus 2x square. You see what's happening? At this is negative 1.414, that is negative root 2. The graph comes and passes through. It is a cross point. At 0, 0, it comes to 0, 0 and then touches and turns back. So 0, 0 is a touch point. And this one here is a root 2, 0. That is your cross point. So these two, there are 3 intercepts, x-intercepts. One is at negative root 2, 0 and one is at root 2, 0. These two are cross points. Graph passes through them, crosses through them. And at 0, 0 is also an x-intercept, but graph comes, touches and turns back around. So 0, 0 will be a touch point. So we did all that analysis using algebra. Let's do one more example. G of x is given to be x times x minus 1 times x plus 3. What are the zeros? Will be 0, 1 and negative 3. Each of these have multiplicity of 1. Multiplicity of 0 is 1, of 1 is 1, of negative 3 is 1. So they are all odd. That means all of them are cross points. So you see here is the graph. It passes through at 1, at 0 and at negative 3. Each of these points graph just passes through, right? So that means we have the multiplicities tells us they are the cross points. Let's look at second part. The zeros here will be 0 from x, 1 from x minus 1 whole square and negative 3 from this last one. And the multiplicity of 0 is 1, of 1. How many times 1? X minus 1 is repeating 2 times. And for negative 3 it is 1. So 0, 0 and negative 3, 0 will be cross points. And 1, 0 will be touch point because multiplicity of 1, 0 is 2, which is an even number. So let's check the graph. Here it is passing through negative 1, negative 3 just crosses. It passes through 0, just crosses. It touches 1 and goes back. So this is touch point. and these two are cross points. It tells us a little bit about the graph. What's a turning point? The turning point of a polynomial function are the points where the function changes from increasing to decreasing or vice versa. You see where the graph touches. The turning point is it's going down and started to turn back. So here in this graph, for example, this would be turning point or this would be turning point because the graph was increasing and then it started decreasing, right? So the points where the graph turns from increasing to decreasing or vice versa, those are called the turning points. These points corresponding to points where we have relative maxima or minima. The graph of a polynomial function with degree n has at most n minus 1 turning points if we have a graph of a polynomial function whose degree is n. At the maximum, it will have n minus 1 turning points. Let's say we have this function x cube minus 21x plus 20. Then what is the degree? Is equal to 3. So maximum number of turning points will be equal to degree minus 1, that is 3 minus 1. How many? 2. So you can see the graph of this function right here. It has 3 zeros because that's the degree. It has 2 turning points, 1 and 2. That's what we said, that maximum number of turning points is equal to 2. Now we learned all that. Let's learn how to graph a polynomial function using all this information. To graph a polynomial function, these are the basic steps. First, I use the leading term to find the end behavior of the graph. Then I find the y-intercept by evaluating f(y) equal to 0. Find all the real zeros and their multiplicities, how many times they repeat. These are the x-intercept. And then I check these x-intercepts are cross points or touch points, and that will help me make the graph using x-intercept and the end behavior. Draw a sketch of the graph starting left end behavior, connect x-intercepts and y-intercepts from left to right. The curve will cross x-axis as an x-intercept if the 0 is an odd multiplicity, so that will be what? Cross point, right? The curve will touch but not cross x-axis if the 0 is even multiplicity. Then we check the symmetry. If the function is even, it is symmetric with respect to y-axis. If the function is odd, it is symmetric with respect to origin. Plot more points with the more accuracy. Let's see, for example, if we have to plot this graph x cube minus 9x.